Here's an example of how they might test your knowledge of slope field diagrams on the multiple choice section. So here's an example of a slope field diagram, and we've been asked to decide which of these differential equations would produce this slope field diagram. So there are lots and lots and lots of approaches. I'm going to talk through how I would decide on this one. Most of the time what I start with is I notice whether I can find places on the graph where the slope is always positive or slope is always negative. So I'm going to look at the different quadrants. I noticed that in quadrant 1, every one of those little slope pieces goes uphill, which means that whenever my ordered pair is in the first quadrant, the slope should compute to something positive. And I noticed that similarly in quadrant 3, whenever my point is in quadrant 3, the slope should compute to negative. So it gives me a little bit of an idea about the relationship between x and y. I noticed this differential equation says that I'm going to take the x coordinate and divide by the y coordinate. Well, I know that this can't be the answer because when I take a positive x and divide it by a positive y, I get a positive result, so I'd have a positive slope. That's true in quadrant 1. But look here in quadrant 3. I would have a negative x in quadrant 3 and a negative y. If I divided a negative by a negative, I should get a positive slope. But all of my slopes are negative. Every one of these goes downhill. I know this can't be it. So, some other things to think about. No matter what x is, if I square it, my result should be positive. If b were the answer, then I would have zero slope. I would have horizontal line slope pieces everywhere that x was 0, and I would have positive slope everywhere else. But I've got this whole quadrant full of negatives. No, that can't be it. Check this out, the natural log of x. I can take the natural log of a number and get a negative result. I can take the natural log of a number and get a positive result, but I can't take the natural log of a negative number. So the very fact that I have slope pieces at a place where my x is negative, natural log isn't even defined for negative inputs, so this can't be my answer. There are a couple other things that I notice here, so I'll tell you what those things are. I noticed that, remember the slope field diagram we made for y equals, or dy dx equals 2x? Every time we picked a new x value, it didn't seem to matter what our y was because our slope formula only had the variable x. So, and what did that end up looking like? No matter what I picked for my y, the slope only depended on the x. That meant that if I picked an x that gave a slope of 0, then I had 0 slopes all up and down this vertical line at x equals 0. And I had all the same slope up and down the vertical line at x equals 1. So when I have my slopes all the same across a vertical line, I'm expecting that my slope is only a function of x. If my slope is always the same across horizontal lines, I would expect my slope only depends on y. But here, I can see that it's not true for either one. I don't have the same slope up every vertical line or across every horizontal line. That gives me a hint already that my slope should depend on both x and y. So I'm leaning toward this guy here. Can I prove that 1 plus x is not my original derivative? So it means anytime x is positive, the slope should be positive, right? Because the slope, if x is positive, then x plus 1 should be positive. But check this out, in quadrant 4, even though those x's are positive, I have negative slopes. So it tells me I can't be here. And this confirms for me that, in fact, I'm right about letter C. It's the only one left. Can I give a reason for why this is correct? Just notice here, another technique I use besides noticing the sign of the slope in all four quadrants and seeing if that can help me. I look for places where I notice the slope is equal to 0. So I see there's sort of like these horizontal pieces that come down at a diagonal. And notice what would happen here. If I had x plus y and I wondered where my slope was going to equal 0, I wonder where I was going to have horizontal line segments. Check that out. That's the same as saying y equals negative x. And look what line my negative slope pieces, my horizontal slope pieces seem to trace out. It's y equals negative x. So that confirms for me that I have the right solution here. dy dx equals x plus y. So here's another way we might see slope field knowledge tested on the AP test. This time I've been given the slope field diagram and a list of possible solutions. Remember, the solution to a differential equation is supposed to be the graph that you feel like drawing when you see a slope field diagram. So imagine these little slope pieces that we have here are all magnets that are programmed to draw the correct solution. So which one of these functions could you draw without upsetting the magnets? So imagine trying to come in here and draw through this with an x squared. There's no parabola that like lines up with those little tiny pieces. Here's what e to the x looks like. Here's what e to the negative x looks like. That's not even right. I'd want to be going downhill. I would have downhill slope pieces. So cosine of x, right? If this is x equals 0, cosine starts at its peak, right? So notice here, I would expect this, if you think about the place on the cosine curve where x equals 0, that's the top of the hill. That's a tangent of 0. That's a flat top on that hill, a horizontal tangent line. And look at how steep my tangent line is. The closest I have to 0, the closest x value I have to 0 has a super steep tangent line. That's not how cosine would work. You could try to draw it in. Now, notice they don't have to be especially forthcoming when they mark this axis. They have marked the number 1 here, which kind of implies that you could get all the way up to almost pi. Can you draw a cosine curve in here? It doesn't feel like it matches, like it lines up with the pieces that are already there. So watch what happens when you try to draw in natural log. It just fits with the pieces. So there's lots of other ways to do this. We could have taken the derivative of each of these and then checked places to see if my slope pieces had the right slope. I do notice that every slope piece in this diagram has a positive slope. So I would only be able to, but that might help me narrow some things down. I notice when I take this derivative, my dy dx would be negative e to the negative x. So again, if I have x's in the first quadrant, my y's are all going to be negative. My slopes, my dy dx's are all going to be negative, but none of these slope pieces go downhill. I know it can't be this guy. And y equals cosine x. What's dy dx? Negative sine of x. So I would have negative slope pieces for x's that were positive but close to 0. So, oh no, it's not this guy. So lots of options you have to arrive at that conclusion. Here's one more example. Notice that says dy dx equals x over y. For some copies that might look like a negative sign. So dy dx equals x over y. dy dx equals x over y. Again, I like to start by analyzing the sign of any quadrant where it seems like all the slopes are the same. like all the slopes have the same sign. I notice here, answer choice A, in quadrant 1, these slopes are all positive, and in quadrant 3, the slopes are all negative, but that's not the case for quadrants 2 and 4. There's a change there. There's some positive and some negative. Here in quadrant B, or answer choice B, those are all negative. These seem like they're all positive, but then I change quadrants 1 and 3. Well, this is interesting. For answer choice C, these are all positive. These look like they're all positive. These are all negative. These seem like they're all negative, so positive, negative, negative, positive. For letter D, these are all negative, positive. These ones are positive. These all seem negative. And notice, the answer choices have no obligation to have like a one sign in a certain quadrant. This is just an easy way to eliminate. I'm not going to move the slide because I'll lose all the stuff I did. But let's look at what I have so far. See, that helps me eliminate any answer choices. Oh, so check this out. So this derivative is a quotient. So it means I'm going to do a division problem. I'm going to divide the x value by the y value, and that's going to give me the slope. So that's nice when there's only really one operation involved, because sometimes you can draw some conclusions. I know if I divide a positive by a positive number, I'm expecting the result will be positive. And my x's and y's are both positive in quadrant 1. So I'm going to look through here the quadrant 1s. I'm only going to leave in answer choices where the slopes in quadrant 1 are all positive. These are not all positive. Those were in answer choice C. In answer choice D, those are not all positive slopes in quadrant 1. In fact, I think they were all negative. Okay, answer choice A, I also have positive slopes, and I'm not showing you answer choice E because it's going to mess up my drawing. So I'm going to continue. Similarly, if I divide a negative number by a negative number, I'm expecting again to get a positive result. So here in answer choice A, it looks like in quadrant 3 I actually have negative results in quadrant 3, but I'm expecting positive. It's not going to be this guy. It already wasn't that guy. So now I'm down to C and maybe E. I've been hiding E, not on purpose, just because I started drawing, and if I move the slide, the drawing gets messed up. So now I'm down to the answer choices C and D. Let's see what I can, C and E. And my derivative, dy dx equals x over y. So notice these were all positive, negative, positive, negative. These are all positive, all negative, all positive, all negative. Okay, so those two graphs both pass my sign test. That's not a real thing. That's just something that Mrs. Hicks does when she sees a slope field diagram and has to pick the original differential equation. So now I'm going to have to do something, make some kind of decision about which of these could be my answer. So I notice here a couple things I could do. I could think about where my slope is 0, or I could think about how the graph behaves as x gets really big or really small, or as y gets really big or really small. So we'll try the zeros. When x is 0, when x is 0, the slope should be 0, right? Because if I have a fraction that's 0 over something, that makes 0. But if y is ever 0, my slope should be undefined. Remember, undefined slope is going to look like a vertical line segment. So that's the next thing I'm going to look for. I'm going to go back to my two pictures. I'm down to choices C and E. And I'm expecting whenever x is 0, that my slope is 0. And whenever y is 0, my slope pieces are vertical. So here, when x is 0, that's the y-axis. Looks like I have all horizontal pieces up this y-axis. And when y is 0, You can see how my slope pieces here are almost vertical near the x-axis. So C is looking pretty good. Oh, well, looks like I have the same thing on my E graph. When my x is 0, I have horizontal slope pieces. And when my y is 0, look, these are all looking like they're vertical. There. Okay, so I'm going to have to pick something else. Things I can think of. When x and y are close in value, this division should turn out to be 1. So imagine when x is equal to y, that's this line, this 45-degree function, y equals x. I'm expecting that if I look along that line, I'll find slopes of 1. So it should almost feel like the line y equals x is graphed in my slope field diagram. So here we go. You see this line that kind of goes through there? It feels like it lines up with that line I just drew. It lines up with the little slope pieces that were there. If I try to draw that line here, you see how it doesn't jive with the pieces that were there. Look at this corner up here, or this corner down here. I was expecting a slope of 1, where it seems like x and y should be equal. And really, I had little vertical line segments there. So that makes me rule out choice C. And I settle on E. Recall that I'd like you to attempt this homework assignment, this textbook assignment, as soon as you finish your notes, before you come to class. We'll see you in class Tuesday.